So today I just wanted to make a video discussing different RJ-45 connectors or registered jack connectors that I've used over the years. Basically, I only use a couple different kinds now. I've sort of tried a lot of them and figured out which ones are my favorite, and there's various reasons for that. Basically, this one on the right is a true cable. Loading bar staggered, loading bar RJ-45, and it's my favorite, and it's my go-to for most of the time. And then down here would probably be my least favorite. This connector, I don't remember where I got this from. I just found it in my tool bag. Probably had it for years. This one is a trip light staggered, non-pass-through RJ-45, non-loading bar. And excuse me, I'm just trying to get over a cold here, so my voice is a little messed up. This one is just a non-pass-through Cat 5e RJ-45. This one's an Ideal Networks loading bar that's not a pass-through loading bar, and the loading bar is not staggered, so that's 5e. This one is a trip light loading bar staggered with 3-pin golden contact. I used to use these for years, and then I moved to the true one cable. Basically, these two are the same. Okay, the difference is the loading bar is colored. I'll get into that in a second. Let's look at the first RJ-45 here. Okay, so this one is not a pass-through, and let's look at the golden contact here now. So I can get this on camera here and get it zoomed in. So essentially, what happens here is that there's two teeth or two prongs on this golden contact, and it's very hard to tell, but they're beveled ever so slightly on opposite sides of each other. So what happens is the wire gets sort of kind of like the IDC on a punch down in a sense. It goes between the two prongs, and it gets wedged between the two prongs, and that happens because the two are beveled the opposite of each other. You see, so it creates kind of an offset when it pierces the wire. You see, this one, I believe, in terms of mechanical stability, long-term mechanical stability, is the worst one here. Okay, I believe the 3 prongs mechanically hold the wire better, and I'll show you why in a second here. So now when you buy RJ-45s, they will specify whether that is for stranded or solid conductor or for both. So they'll be either just for one or the other or for both. Okay, so you want to check to make sure that you're buying the right connectors for what you're doing. Typically, you're going to be buying RJ-45s for solid conductor because you really shouldn't be making your own patch cables. You should buy them pre-made, and I can make basically a whole video explaining why you should not make your own patch cables. Sometimes it's unavoidable, and you need to make a custom long cable for your rack or some sort of specialty setup, and you have to make that cable. But for the most part, buy pre-made patch cables. If you are going to use make your own patch cable, just make sure that if you're using solid or stranded wire, to make sure that RJ-45 is compatible according to the manufacturer. Okay, so this one, okay, non-pass-through, not staggered, so it's a Cat 5e, 2-pin, 2-pronged golden contact. This one, okay, is a trip light. Let me see if I can get the fingers out of the way here so you can focus in. See that? Okay. That's a staggered connection, okay? Non-pass-through. Basically, this one, I used these ones for a few years, and I wish kind of I'd paid more attention to the golden contact portion, but as you can see, it's pretty much going to be the same golden contact as the other one. It's a 2-pronged. So not ideal. Okay, and to be honest with you, these RJ-45s, when they're non-pass-through and non-load bar, are very difficult to gauge the right amount of distance that you need to cut the wire. Because as the wires get shorter, when you're doing your termination, they get more difficult to manage, right, and to make and do correctly. So that's why pass-throughs are convenient, because you can just push the wire all the way through. So long story short, these are very difficult to work with in gauging how much wire you need, because you're not supposed to have more than a ½ inch of untwist in your termination. So these are very difficult to do that. Very fiddly, these ones. Okay, let's zoom back out. This next one is a non-pass-through. It's pretty much the same as that one, just not staggered as the one we just looked at. Now this one is an Ideal Networks connector. I believe I bought it from Home Depot, I want to say. Now this has a loading bar, but I don't know if you can see this. Okay, the loading bar is not a pass-through loading bar. Okay, it's kind of hard to pick that up on camera. Maybe if I hold it like this. Okay, it's closed on the end, which kind of defeats the purpose of the loading bar in my opinion. It's also not staggered, it's straight. So again, it's difficult to gauge. This is more easier than the one we just looked at. It's a step up from that, but not being able to pass those wires through is problematic. So I don't use these at all. In fact, let's look at the golden contact on that now. Sorry, it's a little bit difficult here to show this. Okay. Now this is a 3-pronged golden contact, right? I believe in terms of mechanical stability that these are superior, because now you have 3 prongs holding the wire versus 2. Now this achieves this by, I believe the outer ones have a slight bevel as well, but the inside one is beveled opposite again to the other pins or the contacts, so that the wire basically wedges between that middle one and the 2 outer ones. I just think it's just superior in terms of mechanical stability, because you have to imagine that over the years, due to expansion and contraction, heat, remember there's electricity going through these, especially if you're running PoE and some of the higher power PoE devices, this can probably get warm. So I really think if you're going to go power over Ethernet, you want long-term stability of those contacts. You don't want that RJ-45 failing 5-10 years from now. That a 3-pin golden contact is really the way to go, and that's what I'm only going to use in the future from now on. Okay, let's look at the trip light. Let's look at the loading bar. Okay, let me zoom in here. Now, the loading bar is a pass-through loading bar. Way better, in my opinion. It's also staggered for Cat 6, so you don't have, it helps to reduce near and crosstalk or next. And yeah, this one, I won't show you the contact because it's pretty much the same. It's a 3-pin. Now this is my favorite. Let me just get the loading bar. It's the same loading bar as Trip Light. One has pass-through staggered, but you can see that the color of the loading bar is it's colored. It's green. Now that really helps with distinguishing where that loading bar is when it's in the RJ-45 that's fully pressed to the end and seated properly. With the Trip Light one, the loading bar being clear, it's very hard to tell where you are, and you want that loading bar all the way into the RJ-45 when you terminate. Let me just put the loading bar inside of the RJ-45. I don't know if you can see, that's pretty much how you want it, all the way in. In fact, it's probably a little bit off. But when you terminate it, you want that all the way in, and having that colored helps distinguish the difference between the loading bar and the RJ-45 itself, so you can easily tell where you are. If it wasn't like that, like the Trip Light that's clear, same color as all the plastics, all the same color, it's very hard to distinguish where you are. So, and the just zoom back out here, and the sorry, I was gonna say cable matters. The true cable golden contact is also 3-pin. I'll just show you real quick. Zoom up of that, zoom in of that rather. Pretty much the same design. So, you know, you wouldn't think all these little details matters, but they do. And now I also want to show you why these pass-throughs, not the loading bar ones, but just a typical pass-through wire is not good for data transmission. Because if you look here, right, okay, you can see, hopefully, that, try to get that to focus, okay, that the wires are exposed on the end, okay? That's the actual copper in the wires. It's exposed on the end of the termination, okay? Again, this is a pass-through, 5E pass-through. Now, this is terrible for next, near and crosstalk, because you have voltage on those wires. And if those wires are exposed like that and close to one another, this can cause interference between the pairs. So this is not a good termination for a high-speed network. Slow network, sure. Fast Ethernet, sure. But once you get to gigabit speeds, 1 gigabit, 5 gigabit, 10 gigabits per second, this will not suffice. This is not a good connector for a high-speed network, so don't use these, okay? This little detail matters, right? They're convenient, but, you know, if something's easy and convenient, there's probably a trade-off somewhere else, and that's in performance, okay? So these are not good for performance. Now, you're not always building a high-speed network, right? Sometimes sometimes this will suffice. This pass-through 5E connector will suffice, right? You really don't need a high-speed network. For example, we have a volume controller for an audio system, right? It's a Yamaha audio system. It's an Ethernet-based audio system. So you terminate this, you plug this in, and you plug this into the back of the Yamaha processor, right? This sends very simple network information, okay? It's just a volume controller and 4 buttons for different commands. It's very basic. A pass-through 5E connector would work perfectly fine for this. You don't need to terminate a staggered Cat6 load bar termination for this. So those pass-throughs have their place, just not in a high-speed network. So yeah, I just wanted to go over that, and I guess real quick too, we can talk about sort of I hear, you know, different terminologies used for the different components of the RJ-45, the registered jack. So one that gets overlooked here is the strain relief. So when you crimp these RJ-45s, right? Okay. On top right here, I'm trying to do this while looking at it. Okay. This little plastic, okay, piece gets depressed when you crimp, right? On your tool, this little plastic piece will depress, and it will actually, you see that, come down and hold the, see if I can get this, and hold the wire in place, right? Sort of crimps onto the wire, this little plastic tab in there. Okay, that's called the strain relief, and that's to help eliminate the jacket pulling back from the conductors inside, okay? So that's called the strain relief. I've heard different names for this piece here, locking tab. I guess you would just call this a locking tab that locks RJ-45 into whatever you plug it into. And then you got your 8P, 8C, or 8-pin, 8 contacts, 8 golden contacts right there. And that's pretty much, not much else to that. You can typically tell, without having the load bar, you can tell that this is a load bar design because it's very hollow and very empty. See that? You can tell that there's something missing and that there needs to be a load bar in there. Whereas other RJ-45s, you won't see those exposed contacts in there. So when you look at this, you can go, That's a load bar type RJ-45. All right, well, the video is getting kind of long, so hope you enjoyed watching and learned a little bit from this video. Please like and subscribe. Thanks for watching.